All right. I'll tell you what, for sake of time, we're going to go ahead and just get started. I know I want to get through most of this so that we can try to save some time for Q&A. So today we're going to be going over some of the frequently asked questions that we find come up very often, and we'll go into them in pretty great detail. And I'm sure these will stir some other questions, and we'll just try to get through them. So today I'll be doing most of the presenting. Troy Daniels, technical trainer here at SimpliPhi. We also have Matthew Walker on as well. He will be helping me out when it comes to the Q&A section at the end as well. So he'll be helping out as well. Matt is also one of our technical trainers.
Happy to be here.
Thanks, Matt. All right, so I wanted to start with a little bit about SimpliPhi Power, just to kind of give a rundown of the company for anyone that maybe doesn't know. So let's just talk a little bit about company, chemistry, and really the products that we offer. As far as what kind of, what we do here, what are, I like these top three, as I kind of call them: safe, proven, and simple technology. This is kind of what we strive to always do. Safe as in non-toxic, non-hazardous, cobalt-free chemistry, no risk of thermal runaway. They're UL certified batteries. You can see the various ULs there: 1642, 1973, and 9540A. UN DOT certified as well: 304080, 38.3. Proven technology, over a decade of experience and growth. Batteries going beyond their warranties at this point, which is always a good sign when a company can really live up to their warranty. Deployed in more than 40 countries and 100 megawatt hours installed worldwide, and even tested and validated by the U.S. Army and Marine Corps. And we do try to keep things simple as possible when it comes to batteries integration, optimizing any generation source, maximizing the resiliency, having one battery that you're going to keep for a really long time, and making things as simple as possible. So kind of the base of our products is manufacturing with a lithium iron phosphate chemistry. This is our safe, non-cobalt free chemistry. This is what really defines us as a safe lithium manufacturer. And we use a cylindrical form factor when manufacturing. So kind of an idea of where we are globally. I mentioned 100 plus megawatt hours, 40 countries. We have tons of other countries that we do still ship to. These are kind of just the main hubs here, looking at it of where we really are and where we have distribution centers. Okay. So let's talk a little bit about product line. Really, this kind of standard Phi battery is really our main battery. This is the most commonly bought product currently, and that probably won't change for a while. So it is our 3.8 kilowatt hour battery, and that comes in 151 amp hours at 24 volts or 75 amp hours at 48 volts. These are parallel connection only batteries. They're modular, scalable. There's actually no limit to how many you can put in parallel. I mentioned 24 and 48 volt options, integrated battery management system, and integrated circuit breaker for protection and ease of installation. I just want to pump the brakes real quick, since I did not mention it just yet. If you do have any questions, which again, the point of this presentation is just to answer any questions that people may commonly have when it comes to our batteries, as well as answer the ones we think are the most common. Go ahead and type them right into the Q&A section. If you go up to the top of your screen, you can click Q&A and type in any questions there. Okay. We also provide portable power packs. So things like the Big Jenny and the Little Jenny. These are all-in-one systems that are designed for emergency power, portable power, still utilizing the same LFP chemistry and still the same manufacturing process. Our Express unit, this is one of our mobile units as well. It's a NEMA 3R enclosure, so it is outdoor rated. It's designed for quick connects. So whether that's a DC quick connect in for charging from PV or an AC in for charging from the grid. You can pull power directly off this unit without having to wire it to a critical loads panel. So 4 outlets built into it and 2 USB ports. So grid goes down. This unit can be rolled in from the garage, let's say, fully charged, and you can start plugging various loads into it right away. No hard wiring into them. The access line is another one of our all-in-one units. This is definitely a big seller as well. So we have 2 units, 2 different types of access units, our Solarc access using Solarc components, and our Schneider access using Schneider components. These are DC or AC coupled options. Can be used on new or existing PV, and even through our enclosure as well, so it's outdoor rated. No maintenance, top of the line safety, pre-wired, pre-programmed. A little bit of wiring you might have to do, but for the most part, everything's ready to go out of the box. All right. We also have a high voltage solution. This is not for residential use, at least not on most residents that I know of. We're looking at things like microgrids, large scale backups, so 40 volt 3-phase, external BMS. So it is a different BMS. It's actually an external BMS that runs off a stack controller. This battery can be 200 to 800 VDC nominal in stacking voltage. So meaning that we are putting these in series, and then we can parallel those stacked modules out to build out more energy storage. CAN bus, Modbus, and Ethernet ready. I'm actually going to go ahead in 1 second here. Okay. And our newest battery, if you did not get to join my presentation with Solarc talking about our new battery, I would highly recommend jumping onto our YouTube channel and checking it out. Our newest battery is called the SimpliPhi battery. This is very similar as far as sizing goes, 51.2 VDC, 75 amp hours, so it's still a 3.8 kilowatt hour battery. Some big differences: max discharge at 10 minutes is 100 amps DC. It actually comes with a 100 amp breaker. And this one's going to make sense in a second. It is actually only limited to 30 battery modules in the system. And the main reason for that is it actually comes with closed loop communications. So currently this is with the Solarc inverter. We're going to be adding more inverters on as we go to integrate with. Currently though, the advanced integration is with the Solarc. So this is closed loop communication with this battery direct to the Solarc, giving you auto-populated set points, high level protection. You can actually size smaller than the battery bank to inverter capability, which we'll talk about as a frequently asked question. Super high level accurate readings when it comes to SOC, voltage, charge and discharge. And again, flexible sizing as well. And yeah, keep typing into the Q&A, everybody. We'll save all those questions for the end, and we'll talk about it all live so that everyone can hear. Okay, so let's jump through some of the frequently asked questions that SimpliPhi Power thinks are frequently asked questions. These are ones that we see on a day-to-day basis, and they're definitely worth addressing. Huge one: what is the minimum quantities of batteries I can use in a system? So there's tons of different factors, numerous factors that need to be considered when sizing a SimpliPhi battery bank, especially when considering the minimum. I always tell somebody, start with load calculations. This is always where you need to start, based on a customer's expectations. Is it a whole home? Is it off grid? Do we need to maybe oversize the system a little bit? Is it critical load? Do we have some room to play? This is always the first step. Inverter size and quantity. So this is the main thing that people mess up on. And I'll talk about the SimpliPhi a little bit here at the end, but let's talk just our standard 5 batteries must be sized based on the 2-to-1 ratio, correlating to our C/2 max continuous discharge. Meaning, if we have a 3.8 kilowatt hour battery, we can only discharge 1.9 kilowatts continuous out of that battery. So your inverter must reflect that. So if you have 1 3.8, you need the maximum inverter size is a 1.9 kilowatt inverter. So we would never be able to over discharge the battery. This one's messed up a lot. I see a lot of 8,000 watt inverters with 2 of our batteries. Again, it's the max discharge of the battery bank. So that 1.9 does add. So if you have 3 batteries, it is 1.9 times 3, not just 1.9 for the entire thing. But again, 2-to-1 ratio being the easiest way to solve this. If you have 20 kilowatt, or let's take it kind of backwards. If you have 8 kilowatts of inverting power, the minimum quantity of batteries is just double that. It's 16 kilowatt hours of batteries minimum. Super easy to remember. The 24 volt battery actually has a lower discharge rate than C/2, so definitely check out the spec sheet. It has a pretty low max discharge. I don't recommend using our 24 volt batteries on systems that require heavy loads like air conditioning or power tools or anything like that. Now, when using the SimpliPhi battery, our newest battery, at least when it comes to what it can pair with, so currently it's just the solar, soon it'll be other inverters, you're not required to follow this ratio as far as sizing goes. So you can have 2 batteries on a 12 kilowatt solar. That is okay. And that is acceptable sizing. As the SimpliPhi battery has that communication line and actually has the ability to ensure that the battery does not over discharge. PV size is also something to think about when it comes to minimum quantity of batteries. So if you're AC coupling, you need to consider that your battery also needs to be double the PV array size, or your array needs to be half of the battery bank size. So if you have 10 kilowatt hours of battery, you do not want more than 5 kilowatts of PV. Charge controllers, not a problem. We can always hit the limit on it. We can hit a limiter on a charge controller. So you do have a little excess PV and it's DC coupled, you can always use the charge controller to minimize that production. If you're looking for tools to help size, I won't go through these too much. Let's see if this jumps me out of the presentation properly. Okay, so let's just minimize this. There we go. Sorry about that. This is our quick battery calculator, so a little bit different than our more advanced one I'll show you. It's just really going off of average consumption, days of autonomy, and what voltage you want. Now, okay. That being said, we do have an advanced calculator. It's a bit different here. So, it takes a second to load. It is a pretty large calculator, so you just got to give it a minute. This calculator is really designed to take into all these factors I just mentioned. So I mentioned, PV can be a factor in minimum battery quantity, inverter size, load requirements. This takes in all of that data and will help you size based on that. So this is the one I would recommend if you are, you do want some help sizing the battery. All right, same vein, what is the maximum quantity of batteries I can use on the system? This one's a bit easier to follow. So typically, first and foremost, I'd say there is no limit to how many of our standard 5 batteries can be put into parallel. Load calculation, I'll still always say that's key. That's going to be your #1 starting point here. You don't want to just size because you can. But again, the 5 battery, the standard battery, has no limit to how many you can parallel. The SimpliPhi battery does have a limit. It is 30 batteries in parallel. That's due to communication cabling and the actual networking. So currently that is 30 batteries in parallel of those 3.8 SimpliPhi batteries. This question comes up a lot, kind of piggybacked off this main question, is when should I switch to the high voltage from your standard, let's say 48 volt product? It's really mostly going to be based on your AC requirements. So let's say your requirement is 480 volt 3-phase for a project, then it's definitely going to make sense to go ahead and switch to a high voltage product. It's going to pair with the inverters that you need to get that 480 volt 3-phase. And it's going to be able to handle that power that's really required in those situations. And if a power requirement that exceeds a 48-volt inverter's paralleling capabilities, this is often a good time to switch over to our high voltage as well. Okay, another common question that comes up, where can I purchase SimpliPhi batteries? So, SimpliPhi really does sell through a distribution network, meaning we do not really sell direct. We really rely on our distribution network. It allows our installers and our customers alike to maintain lower cost, easy shipping, and quick stock. So it tends to be cheaper using the distribution network either way. If you're looking for where to buy, you definitely want to look towards our where to buy page, which includes our distributor network, but also our installer qualified, our IQ program. So these are installers that have gone through this program, not a requirement to install our batteries, but they've gone through this program and actually have a spot in our map. So if a homeowner maybe looks at, where they should get their battery installed from, the installers that have gone through this program, they'll be on this map here and their company will show up. So here's a company here that's actually showing up as somebody that we know has gone through the process of going through these trainings, taking the test, and completing 2 installs. And they actually get to land on our where to buy page as well. But to actually buy, as an installer, we have our various distribution partners located on our where to buy page. So no matter where you are, you should be able to find the closest distributor there. Okay. Can I add a new battery? Can I add new batteries to an older SimpliPhi system? The answer is yes, you actually can. So one of the greatest benefits of our batteries is that ability to add new batteries to an old system. I typically stick within a 3-year recommendation, meaning that if it's over 3 years, I would tread lightly as far as adding new batteries in, as there might be a lot of balance issues. The newer capacity can be combined with the older capacity. So I know it's kind of confusing, but the next part will clear that up. So there's no mixing of these 5 models. So for instance, the 1.4 and the 3.8, only same models with new capacity can be mixed. So before the 3.8, we actually used to have the 3.5. That was the older model of that specific battery. Before that, it was the 3.4. So you can mix those ones, but you don't want to mix our smallest 1.4 with the 3.8. We don't want to really mix amplifying the standard 5 batteries. There's really not a lot of point to it, first and foremost, as you will want either all of your batteries to have that communication ability or none of them. So it really wouldn't make a lot of sense. Now, as far as warranty goes, the warranty does revert to the oldest battery in the system. So if it is 2 years and you put in new batteries, they are going to revert to that warranty of the original batteries. Okay, how do I replace my lead acid battery bank with SimpliPhi batteries? This is a really common question. I'd say this one comes up on a weekly basis. So they are really designed to be easy drop-in lead acid replacement, but it's always important to confirm your existing equipment is compatible with the SimpliPhi batteries. I like this little call us thing that was put in here. Really do call us. We can help you out to make sure that everything is compatible with each other and just to double check things. So definitely it's always important also to use our most recent integration guide to reprogram all of your equipment from your charge controller, your inverter charger, and really stick with those most recent guidelines. You don't want to just throw a battery into a lead acid replacement and it just uses the old settings. It will not work. You'll probably damage the battery. You really need to do some reprogramming. But when replacing a lead acid battery with a 5 battery, you can really save a customer money, provide them more power, more energy available in way less space. It does not contain toxic chemicals and does not require maintenance or ventilation. So it's definitely a win-win for the most part. I think people oftentimes look at the upfront cost. It's important to understand that the cost over time is always going to be, I've never seen it not come out to be in the SimpliPhi battery's favor as far as what we stand by with warranty and how long the battery is going to last compared to lead acid. So ignoring upfront cost, but looking at overall ownership cost. We've got some good guides here that can help out a lot when replacing a lead acid. First and foremost, this document here is it's a lot, so I'm not going to go through it too much, but this is the ultimate guide for lead acid replacement. It goes through benefits, it goes through charging, it goes through compatibility, it goes through even cost here and how to calculate that properly. So it's a really cool guide. It's on our website. We'll send out the presentation to you so you can get it from there, but it's a really helpful guide when it comes to replacing a lead acid battery. Now, an even easier tool for sizing a lead acid replacement is to use our lead acid replacement guide. So you can actually type in your old battery here and you can get a value. I guess I could do this one probably really quick here. So let's say we had 200 amp hour battery. So let's go bigger. Let's go 500 amp hours. And we have, let's say we know that the battery was using 30%. The lead acid was. We want our new battery to be our 3.8 48 volt battery here. And it just goes, rounds the number and gives you the exact quantity right there. So you can see 2 batteries to replace that. If you're looking for that original guide I just had pulled up, this one, it's actually at the bottom of this page. Okay. So oftentimes this question comes up too, and that is, what is the function of the battery management system? It's a good question. And we really have to kind of divide this into 2 categories. I'll preface by saying the kind of top sentence here that the lithium batteries in general require a battery management system. It maximizes and sustains the performance, protection, and function, lifespan of the battery. And it's important to understand not all BMS share the exact same function or perform on the same level. So that's also true of our products here. And SimpliPhi has varying BMS functions depending on the product. So when using our standard Phi batteries, the BMS is, first of all, an analog BMS. It's internal only, meaning no communication. As far as the low disconnect protection, it does have that built in, and it will disconnect. It even has some other protections built in, but these are I would never rely on these protections, as this analog BMS is really more there to do functions like keep the battery healthy over time. Cell balancing is its most critical function, I would say. And really we rely more on, in that case, the protection built into the charge controllers, into the inverters, more than the BMS. This is why programming and sizing are so key when it comes to that standard Phi battery. The Amplify, on the other hand, is analog and digital as far as the BMS goes. Again, closed loop communication, currently with Solar, but tons more inverters to come soon. Charge and discharge protection, over voltage protection, under voltage protection, even as temperature protection, the ability to disconnect if it sees a temperature it does not like to charge at. And again, automatic set points. So leaving basically even less room for error. So the point being that the battery management systems do greatly differ. Not saying one is necessarily better than the other. It just depends on your application. Now, the analog BMS put into our standard Phi batteries is absolutely capable of giving you a long-lasting, really efficient battery when sized and programmed correctly. The Amplify battery is more for advanced integration and maybe a customer that wants to see more of an advanced level there. Probably my favorite question, as it comes up a lot, and it is a tricky one to answer oftentimes. How can I determine a SimpliPhi battery's state of charge, an SOC? Tough question to answer. First and foremost, the SimpliPhi batteries have a really narrow voltage window. And they have the ability to see voltage drops and voltage rebound, meaning if a heavy load comes on to the system, it can often drop a couple volts even sometimes and maybe recover really well that you would not see out of other battery types. This is really common with lithium iron phosphate batteries. So you won't really see this as much in lead acid, this really high level dip and recovery. And this, especially as far as this narrow voltage window goes. So this often causes older battery monitors and technology not to properly read the battery state of charge, as it's designed typically not around lithium batteries. So there's some quick notes here. The 5 batteries charge at a higher voltage, such as around 56 for our 48 volt models. However, these batteries have a resting state of charge, which I typically define as load being on the system and batteries no longer in a state of charge. At about 53 volts, they're 100% charged. The battery is fully discharged at 48 volts in a 48 volt situation, 24.0 in a 24 volt situation, and 12.0 in a 12 volt situation. So when it comes to battery monitors, older monitors tend to be very inaccurate and take a great deal of time to calibrate. So, you know, it just depends on the exact monitor you're using. I would always say no matter what, they're going to take a while to calibrate, and any accurate reading you're going to get is going to take some pretty precision-based set points, which we do typically have in our integration guides. So if it's like a Schneider battery or a battery monitor kit, you know, you can go into our integration guide for Schneider and see exactly what we recommend set points are. Now, the SimpliPhi battery, our newest battery, can directly communicate with designated inverters. So again, currently the solar, but more to come. And this leads to a really high level of accurate SOC reading. Basically taking that battery monitor out of the situation, and the SimpliPhi battery, the SimpliPhi specifically model, will report its own SOC, which is highly accurate. Okay. How do I wire my SimpliPhi batteries? This is a good question that often comes up as well. So they're really designed to be flexible. As far as design and installation goes, small, they're small, they're compact, they're building blocks. So they really are designed to be flexible. But there are certain guidelines to our wiring. We do try allow a certain level of creativity, but there are certain guidelines we just don't. So our standard 12, 24, and 48 volt batteries are designed for parallel connections only, no series connections there. If you're using battery cables to make connections to, let's say, an inverter, or maybe, you know, we'll talk about this in a little bit, like a power panel or something like that, make sure that the cables are same length, same size. We also have some other options here. So an installer can also use battery terminal bus bars, such as those that we use in the access units and the BOSS cabinets. Those lay flat across the terminals. Those are really easy to use and helpful. When using a large number of batteries, it's important to use a battery combiner box for the most part. So this helps make the positive and negative connections from the batteries. And then from there, you have the ability to run to whatever connection points you're looking for. You can purchase these from most electrical outfitters and distribution partners of SimpliPhi Power. So if it's one of our distributors, they likely have access to these kind of battery combiner boxes. We also sell the BOSS cabinets. These are NEMA 3 rated enclosures that do house 6 or 12 batteries, depending, well, I should say the BOSS 6 holds up to 6, while the BOSS 12 holds up to 12. These make wiring a little bit easier. You still most likely would want to purchase bus bars with it, but you can definitely wire up a little bit easier. Now we have a full document here regarding wire resources and wire guides. It's online on our website, talking about the different functions of wiring, how to function to in this case, we would wire to a power panel, battery combiner here. You can see here, this is the 12-phi batteries parallel in a midnight combiner box. Using terminal bus bars, incorrect wiring methods, you know, our access solution, if you just need some ideas. Basically, it goes through all of the what to do's and what to don't about wiring. And it can be a really helpful tool if you're looking to, you know, maybe you've got a larger system that you need some help wiring on. Okay, so that was all of our kind of standard FAQ questions that we wanted to kind of touch base on. I will open up the Q&A here, and let's just see what questions we might have. And Matt, let me just take you off mute here if you're not. Okay, Matt's online too, so Matt will be here to answer questions too. So I'll just go ahead and jump on the first one here, and we'll just take turns. So how to access a copy of the presentation and share with my colleagues. We'll send it out after the presentation. Sometimes it takes just a few days, so just be patient, but we will send out a copy in PDF, and likely it'll be on our YouTube channel as well.
Cool. So did I understand correctly that your batteries are only available in 24 or 48 volts? What if I want to power 12 volt DC loads? I suppose I cannot directly connect to the battery. So is there an easy solution for this? Well, you are correct. Do not power 12 volt DC loads directly from a 24 or 48 volt battery. That'd probably hurt the loads more than the battery, but in general, it's just not a good idea. And yes, there is an easy solution for this. We actually do sell 12 volt DC batteries. So check those out on our website as well.
Awesome. All right. The PV sizing rules, PV watts equals 1/2 battery kilowatt hours. Yeah, the 2-to-1 ratio. Apply for grid-tied battery backup systems, which can charge from the grid. I ask because I might have more storage when I backed up. If you answer, okay. So it only applies, the PV sizing only applies when it comes to AC coupled systems. So it doesn't matter if you're grid connected or off grid. It's just simply if you are AC coupled. I don't want to go too much into detail. It's a pretty long explanation. Check out my AC coupling webinar on the YouTube channel. I go into some pretty heavy details of why that is. But again, when you're DC coupled, you can always set the charge controller to limit the PV production, and it will work very well. AC coupled, it has that ability to set that, but it's pretty rare that it works exactly how we want it to. So that's why the sizing requirement for PV being that 1 to 2 is really based only on AC coupled systems.
Perfect. And just to clarify, if you're unsure if your PV system is AC or DC coupled, if your PV system is running through a charge controller, it's DC coupled. Can I buy in Afghanistan? I saw on the map Afghanistan is there. Yeah, I'm not aware of a specific distributor in Afghanistan at the moment, but I do believe there is one there. Troy, do you know?
Yeah, I'm not sure if there's a specific one on the map there, but definitely, you know, that when it comes to these tricky ones like that, I would just say go ahead and shoot. So you can see my email there, training@simplifypower.com. Shoot me an email direct. I'll pass you off to our sales team so they can get you in touch with a distributor that would at least be able to facilitate that.
Cool. And then I can take this one as well. Are there specific charge controller brands and models that must be used with SimpliPhi batteries in order for the battery warranty to be valid? If you're unsure at all if your equipment is compatible, just shoot us an email or give us a phone call, and we'd be happy to verify that for you. Ultimately, what we're looking for is if the charge voltages are programmable. So, for example, if you can set the controller to absorb at 56 volts for 6 minutes. That's the most important thing.
Awesome. All right. Let me just get rid of that one there. I am from Jordan, and we are moving to off-grid and hybrid solutions. So is your product suitable to use as a backup against diesel generators? Absolutely. Probably one of the biggest uses we see is residential hybrid style systems like you're talking about there. So if you need design help, again, I know I keep saying this, broken record, but reach out. We're happy to help out there.
All right. I had a few very helpful exchanges with Matthew yesterday. Well, thanks so much. When Phi batteries arrive, they are essentially quote unquote dead at 20% SOC. When replacing a flooded lead acid system, how do we get them fully charged as recommended prior to putting them into service? It is generally impossible to shut down the entire system for a day or two to bring them up. Great point, Moby. So definitely one frequently asked question that we probably didn't cover too thoroughly here. So I'll do my best to answer that now. They are shipped dead at 20, not dead, but they're shipped at 20% state of charge. I believe that's because of safety regulations around transportation. And when you're replacing a existing battery backup system, it depends on your situation. A lot of people are grid tied and have the ability to just use an external charger or immediately force a grid charge on the batteries through the inverter. But for people who are off grid, do understand that's a little harder. So that's when I'd recommend maybe using your generator. As soon as you get them installed, we just ask that you turn off loads or keep loads to an absolute minimum while you're charging these. And it shouldn't take a day or two to charge. They can charge as quickly as 2 hours with the right source. Anything to add to that?
Yeah, and just a little bit to add to that. Again, I mean, it really kind of comes down to we want to get that battery to a full state of charge before we start connecting loads to it. So that means programming the system, then charging, then really allowing for the battery to get that full state of charge before we connect, AC loads. If you cannot turn off your AC loads, there are some options here. It's really just about keeping them minimal. So let's say you have 800 watts of loads running, maybe, let's say you have 300 watts of loads. Maybe you just need to make sure your fridge is turned on for the day, but you can, in your basic appliances, but you can really let it sit at that minimal load while it's charging, then you're probably okay. So if you've got, 5,000 watts of PV going into the battery and the house is only pulling 600 watts, you're probably okay. When we run into issues is when somebody maybe has 2,000 watts of load and they're only charging 1,000 watts into the batteries initially. Now these batteries are in a state of discharge. We do not want these batteries in a state of discharge right out of the box. That'll really have some adverse effects on the batteries. Did you send out IQ presentation already? I may have missed it. Is there a link? I'm not sure which IQ presentation specifically you're talking about, but go to our YouTube channel. That's the easiest place to find all of these presentations, and that's the most up to date. I'll go ahead and answer this one too. Actually, I'll answer these two here. How long will it take for the power to cut off and the SimpliPhi to start on? So it depends. If you're using our access solution, we're talking microseconds here, and that's just because of the inverters we're using. But really, it's not about the battery in this case. It's about the inverter. So it just depends on what inverter you're pairing with. If you're not using one of our all-in-one solutions, you have to look at the inverter manufacturer's transfer time. But typically, any battery-based inverter is going to be milliseconds. Now, I will say that not all of them are UPS rated technically. Our Solar unit is actually UPS rated. So if you are pairing with a Solar inverter in our batteries, that actually is UPS rated, uninterrupted power supply. And then I'll answer the next one real quick. Is it compatible with the ABB inverters? Depends on what you're talking about there. I think that probably is related to our access again, but again, that's more on the inverter than the battery. So, all right, now I'll let you hop in here again.
Is SolarArc SimpliPhi's preferred recommended inverter for SimpliPhi batteries? We certainly love SolarArc's equipment, and it is definitely compatible, although you can use several other inverters if you prefer those. However, the SolarArc is definitely the preferred inverter for the Amplify batteries. That's what's going to allow you to do the state of charge and other monitoring.
Awesome. Okay, so it sounds like we're having some sound issues. Matt, am I okay sounding here?
You're okay to me?
Okay. Sorry, that might be on your end there, but we'll be sure to send the presentation after. Question, I'll answer these last two here. Oh, okay. I'm getting to you, I promise. I see it. I think you're in order there. Is it safe to be used in hospitals? Absolutely. Again, lithium iron phosphate doesn't have the same properties as you might see with other lithium chemistries. Definitely not lead acid, non-toxic, cobalt-free, safe chemistry, not going to catch fire on you as well. So it is a safe chemistry to use when it comes to places like hospitals, schools, whatnot. All right. Last question I see up here. Feel free, again, we got a little bit of time here, so if you have any more questions, you can type them in now. Still not playing nice with SMA Sunny Island. So we have had some issues with working correctly with the SMA Sunny Island in the past. This is due to using the lead acid settings, is the only one we were allowed to use, and the SOC-based algorithms. So that being said, it is on our list. We are working towards it right now. And it's definitely on the list for the amplified battery. So once we have that direct comms link, that closed loop communication with the Sunny Island, then we will be absolutely ready to go on the approved list, it's looking like, and super easy to work with the SMA Sunny Island. All right.
Outback FXR is definitely compatible. The main thing you just want to check on is the number of batteries you're using. Follow our sizing guide and we can help you out if you're confused.
Awesome. Why don't you go ahead and answer this? I think you're well suited for this one, the generator question here at the top.
Do we have any visibility study against the generator? I'm not sure exactly what you mean by visibility study. I guess.
I think probably just comparing, diesel consumption maybe and versus, savings regarding batteries. I guess kind of similar to your presentation.
Yeah, so our batteries are going to drastically reduce diesel generators runtime. It's depending on where you are, it's a very quick payback period compared to a diesel generator, and it depends on your size of your load, but for most people the payback period is really quick, and especially it'll help you save time in gathering fuel. Depending on where you are, that may be harder or easier as well. And another important thing to consider is the environmental aspects of diesel fuel. I believe the batteries are about 10% of the environmental impact or less of diesel fuel. So hopefully presentation coming on that in the future.
Yep, absolutely.
Where we can give you more details. Float charge cannot be disabled. What do you recommend? That's not really a problem. It's just wasteful if you're charging from the grid. We actually do recommend float charge if you're charging from PV, but I would just recommend charging at 54 volts for float charge if you can't disable it for our 48 volt battery.
Yeah. When installing SimpliPhi batteries with the Victron inverters, would you use the BMS of the Victron? No. So I think you're talking about the external BMS Victron has. I believe that's a product. No, we would just use our batteries. We've got tons of paired systems with Victron. We do not have the closed loop communications currently with them. So we will have that coming out pretty soon, I'm hoping as well. List of inverters to come out. While we're on Victron, we have a presentation, Matt and myself actually, coming up here with Victron Energy. I believe that is probably in the next couple of weeks. You'll see it live pretty soon here as far as registration link goes. I think it's 2 weeks from now, maybe. And we're going to go over mobile applications using the Victron inverters and the SimpliPhi batteries. So definitely, if you want more information on that, shoot me an email. But it should be up to register, I would hope, in the next week. All right. Looks like we got through all the questions. I know that was kind of short and sweet. Again, we just like to come together and talk about frequently asked questions sometimes, try to help answer questions. So we do really appreciate everybody joining today. And we'll try to get some links sent out here with these slides in the presentation. Again, if you need to check out other presentations, just hop on our YouTube channel, search SimpliPhi Power. You're going to see a ton of different presentations on there that cover a wide variety of topics. Matt, I just want to thank you as well for hopping on and joining me. Um, it's been a super easy and good presentation.
Thanks for having me.
Thanks everyone.